5 times 5 is?
25.
Yeah. Hey folks, welcome out there. It is Tuesday afternoon. Mathline, you are at the right place, the right time, right everything, including right frame of mind. Hang in there with us. I'm Ernie Roberts. I'm your host for this afternoon. And you know what? We've got a great show planned for you. We would love for you to be a part of it. Yesterday we had some great calls that came in, all right? And a couple unexpected ones. So what happens? It does happen, yes. But we want to hear from you. 844-686-2378. Want to hear those numbers? I know it's getting close to the end of the year, and some of you are taking some big important tests the next week or so. So give us a call. Let's get some help to you there. We would love to take care of you this afternoon. Again, that number 844-686-2378 doesn't cost you a cent. The advice is free. Hey, what have you got to lose? And plus the fact you get to talk live on the air with me. How about that? And we'll work out those problems live together. But to get us started and get us thinking a little bit, all right, let's check out our problem of the day. And the problem of the day, it's wordy, isn't it? It's a lot of words. In fact, there's no real answer until we get to the very end. So let's see where we're going to go here. Solve for y in terms of x and z. Two variables there. Actually, three variables when you count the y. In the following literal equation, all right, here's that equation. 3x minus 2y equaling 6z. Why do we call it a literal equation? Because we've got a lot of letters in there, all right? It's verbal, very verbal here. But then we will find y if we know x equals to -4 and z equals to 7. So this is really in two parts. We want to get y by itself, then we want to use that new expression and put in our x and z values here. So let's see where we're going to go on this problem. I think we got enough space here. Let's play it out. First of all, again, the game plan is to get y by itself. That's what solve for y means, all right? That's what that means. Now, when we go there, we are going to take our equation that we've got here, and that is going to be 3x minus 2y equaling to 6z. And what we want to do, we want to get our y by itself, all right? So the thing that's keeping us from getting y by itself, well, let's see what's happening there. You've got a 3x. Well, 6z is fine. 6z is good over there. So we are going to need to subtract 3x from both sides. And what happens here is I lose the x's. They're going away. But I'm left with this minus 2y hanging on right there, okay? On the other side here, we have negative 3x plus 6z. Now notice I did not come back and say, let's make some new combination and get 3zx or something like that. You've got to keep them separated, my friends. Negative 3x, right there it is, plus 6z. We leave it alone. We still have a negative 2y over there. So everybody good on that? As you're following along here? I hope you are. Playing along with us is what we got. Now, I want y by itself. What's keeping me from having that? Oh my goodness, it is the negative 2. And that's hooked in by multiplication, so we're going to divide. Now, here's where things get a little interesting. Over here, we're going to divide also everything. Now, you can separate this out, and you could leave it, in fact, right here. These 2's go away. The negative 2 divided by negative 2 gives us y. And you can say, well, that answer's done. There's one option. Let me write it right here. Plus 6z over the negative 2. That's exactly what we have there. No more changes. But there's another thing we could do. We could keep also, let the y go here. And let's say we don't want a negative 2 left in our denominator, which very well could happen. So what we're going to do, we're going to need to divide everything through by negative 1. Not only the negative 2, but the negative 3x and the 6z. So all three of those need to take a little hike. So we're going to make that 3x go positive minus 6z all over 2. There's another possible answer. My goodness, you say you're going to put another one out there, Ernie? I am going to do just that. All right, let's see what else I can pull out of the hat. I can also make the 2 basically divide into both of those, and I can end up with y equals, how about it? 3/2 of x. And you can divide 2 into the negative 6. And notice I have to be able to divide into both, but this left me with a little fraction, so just write it so don't lose the 2. It's still important. And then we'll put minus 3z out there. That's another way we write it. Each of these expressions would give us the same values. Are you kidding me? Yes, for y. Let's check it out and see. At least we're going to go through one or two of these. Which one do I want to choose? 1, 2, 3. How about it? Let's see what happens with the y. I'm going to go right down the middle here first. Let's pick up y equaling to, you got it, 3 times -4 minus 7 times 7. In other words, we're going to replace x and z with our numbers. That's so easy because we got it ready to go. And we're going to multiply, subtract, and then divide by 2. Boy, there's a lot of order of operations in that expression, isn't there? So we've got a -12 minus 42. All that divided by 2. And you know what that gives us? Well, it gives us a lot, doesn't it? That's going to give us a -54 over 2, which comes out to a -27, all right? Now, the question is, would all these other expressions do the same thing? Let's do a quick check on those. Put your -4 right in there, and put your little 7 right over there. Now, some of you are going like, well, those are going to be smaller numbers than we started out with. They may be, all right? So let's see what that does, all right? This is going to give us y equals, my goodness, we can lose the -4 of times, that will give us a -6 minus 21, and look what that gives us, -27. So what I want you to notice is they are equivalent expressions, and we go right back over here because this has got a lot of negatives, doesn't it? See what happens here. I bet you the same thing. We're going to eventually come up with, you got it, -27. But for those of you doubters, that's what I'll do here. -3 times -4. Add, what, 6 times 7? But this time we divide by the -2. Now remember that negative times negative goes positive. So we have a 12 plus 42 divided by -2. But you know what that gives us? Again, -27. Now, let me point out one more thing. We've got a quick moment here for the problem of the day before we run out of it here. What if I had gone back and just used this original equation and put in the -4 and the 7 for z? Would I come up with -27? Absolutely, because this is where we started. This is where we finished 1 round, finished 2 rounds, finished 3 rounds, and my friends, they're all equivalent expressions. When you put the x, y, and the z that we've got here, which is -4, 7, and that -27 back into the picture, they all check out very nicely, very well. And that, my friends, is how we work with formulas, okay? When we start using more than one variable in a formula, the idea is that they should work whatever manipulation we do, as long as they're legal, they should still give us nice equivalent expressions. And there you have it, problem of the day, a little deeper than maybe you thought it was going to be, but again, pointing out how we work with formulas. So let's get those calls coming in, all right? 844-686-23, and that's a 78 added to it there. Again, 844-686-2378. We had some good calls yesterday, made the show rock. We want to make it rock again today. This is Tuesday afternoon. It's a beautiful day outside, but you're hanging out watching Mathline on TV. Pretty cool place to be also, all right? So give us that call, 844-686-2378. Let's get our operator working away today, all right? We want that to go. We really do. We like to work problems for you and help you out, get you ready for all these tests and things that you're taking in your school years with. But we'd like to hear from you guys too, all right? So we can work some problems out live on the air together. So give us those calls and we'll see where we can go. All right, again, that number, 844-686-2378. While we're waiting for a call, let's take a look at an equation situation we've got going here. And it says, write the equation of the line with the x-intercept -4 and y-intercept of -2 in slope-intercept form. Boy, that's a lot of stuff going on, isn't it? So we're looking for that infamous slope-intercept form. By the way, for those of you who hear me say that a lot of times, you're wondering, what is he talking about? So let's put one little notch over here. We tend to use, hey, a literal equation, right? Formulas there. But it's very simple. We are looking for a y value that will work with an x value if we know the slope and the intercept. So in other words, these become our variables. These become basically constants that force things to happen with this expression or this situation we're looking at, this problem situation. So first let's talk about what x-intercept is. X-intercept is when the y value equals to 0. So let's put a -4 and a 0 right there. And the y-intercept will be 0, -2. That's our story. And we have it going there. So let's see what happens. We can put that into, well, we need a slope, don't we? because those are just points. We have a y-intercept. That's good news. Guess what? That's your b right there. That, by the way, that b, that intercept, that slope intercept, comes back to the y-intercept because we're leading with y right here. All right, so that's the y-intercept. Think of it that way. We don't usually try to lead with x because it's a strange little graphing. We're always thinking with the y coming first, right? Everybody's got that. Nod your head, yes. Now, what we need is a slope. So how about it? Let's go with it. Slope equals, it's the rise over the run. Those are the two words we use a lot of times. So how about it? Y2 minus y1, all that good stuff over x2 minus x1. Storyline, here we go. Oh, by the way, which one is which? Well, we don't, it doesn't matter, but as long as we're going to label them, let's put first x, first y. How about it? Second x, second y, right there you go. Now, where are we going to go from here? We're going to do some substitution. We're going to put some numbers into place, and let's see where this little puppy goes. Hopefully to get us a nice slope. We have, what, y2 minus y1? What is our y2? It's a negative 2 right up there, right? And, oh, we're going to subtract 0. Well, that wasn't very difficult, was it? That works nicely. How about the x1 minus x2? Well, did we do that? Well, yeah, we actually did y2 minus y1, so let's keep going the same direction. We do not want to say negative 4 minus 0. That would be bad news, wouldn't it? Although it would be easier, probably. Let's take it and do what we did here. Let's take our second x, which is 0, and subtract a negative 4. Always keep your pattern going. In other words, once you choose first x, first y, second x, second y, keep that pattern working when you're doing slope, by all means. By the way, when we say subtract a negative, that's like adding a positive. You got it. Add the opposite there, right? So let's put a plus, a positive, and that's going to give me negative 2 over 4, which equals my slope of negative 1/2. My goodness, I think I've got the ingredients, don't I? We have the ingredients because you're watching along with me. You're working the same thing through. Remember we said there is one of our ingredients, that's B. There is our, you got it, that is our M. M, by the way, stands for slope. Don't ask me why. I think it's because S's look like 5s. That's what I always tell my students. But the M is basically what we use it's a nice letter versus an S, okay? Some of you are kind of wondering about that. Let's see what we're going to do now. We're going to keep the y open. We're going to keep the x open because they're allowed to change. They're variables that are going to help us out. But we have a negative 1/2 attached to that x, and then we're going to take minus 2. Now, let's take this to our graphing calculator, all right, if we can do that. Let's see what I can do. Let's see. So we got y equals, how about it, negative 1 divided by 2. We'll put that x in there, and we're going to subtract. Now, make sure, sometimes when we use these graphing calculators, we want to make sure that's a negative, okay? There's a different key for that. Notice it's down here with a little parenthesis, so be sure you tap the right thing. This says we're going to subtract, and we're going to hit the graph on this and see how it looks, all right? And let's see what happened there. We have, let's take a look and see what we're going to do. Everybody got it there? Let's trace. Let's see what happens. I've got to trace. There's my intercept. That was good news. My other question is, does it land at negative 4? Well, let's find out. Negative 4. And we enter there. And my goodness, it looks as though we have, hopefully, a good little match there. Hang on to that one just a second. And we'll see what we can do. All right. The situation there, let's come back to our work here. I believe we're good, right? Negative 4, 0. So there you have it. And what have we got going on here? A nice linear equation, easy to graph, easy to check. I love that trace factor. We could also put this on graph paper, just good old grid, and you would have the same thing. In fact, it would really have been easy to connect, would it? Because you would have 2 points already. Just put these 2 points there, draw the line, count the blocks. And by the way, that was going on in a negative direction, right? Negative 1/2. So there you have it. A little bit of look at, we've done a lot of linear equations, literal equations there to get you started. I tell you what I'd like to do at this time, guys. Let's take a Mathline moment, all right? How about that? There it is. Hey, Mathline. Okay, there we go. And I said,
Hey,
hey,
Mathline, this is Samaya from Bearden High School in Knoxville, and I'm hoping you can help me on this. What are the excluded values for the expression 6 divided by x squared minus x minus 42?
Woo! Look at that. Listen to that. Samaya, thank you from Bearden High School helping us out on a Hey Mathline here today. And it's kind of a crazy sounding expression. It says, what are the excluded values? So many times we're looking for things that work. This time we're looking for things that don't work for the expression. And it says 6 divided by, and a big parenthesis there, which we're going to translate to a denominator, all right? A big denominator when we put it on paper here. But it's x squared minus x minus 42. So let's see what Samaya's story is all about, all right? So let's take a look at our paper here and see what we have going. We have a starting point here. It says, what are the excluded values to the algebraic expression? Well, you say, Ernie, what do you mean, things that won't work? Well, you know, the things that we want to make sure will work or won't work happen in the denominator. This 6 is fine. Don't worry about our 6. Our 6 just does a wonderful job there. It's by itself. But this x squared minus x minus 42 is where the problems lie. Because there are possibilities that we could get a 0 out of here. You go, oh my goodness, a 0. Well, what's so bad about a 0? If you've ever tried to divide 6 by 0, you have problems because it won't happen. It doesn't fly. You cannot divide 0 into a numerator, all right? You can have a 0 in the numerator, but you can't have it in the denominator. So here's the problem. We want to look for the values. As she said, we're going to exclude, all right? We're going to exclude for x squared minus x minus 42. We're going to let that equal 0, all right? And we're going to factor. We're going to break this thing open like so. And it's going to give us, it looks like an x minus and an x plus, all right? Like I said, don't worry about the 6. That 6 is fine. But what we're going to worry about is how do we get the number 42? How can we multiply? Let's take, how about it? Why not? Let's take a, you know what we can do? 7 and 6. That works. Think about it. How can we multiply? Let's look at some ways to get 42. There's 6 and 7, which are close together. And I'm going to go ahead and tell you, that's the combination we want. Because we have a minus 1 hanging out right there in the middle. And if we could work with that, that's going to give me a 7 and 6 going right there. You say, Wernie, how did you know that? Take a look. This is what we call FOIL, double barrel distributed, all sorts of good things, but we're multiplying the two binomials to check. See if we get back to the middle. X times x would give us x squared. That looks good. And we know 7 times 6 gives us 42. That's a good news, all right? That's the first and the last. But we want to know about that FOIL business, the outer and the inner. So let's take a look at outer. You have what? 6x. Inner, negative 7x. Piece those things together, and you get that negative 1 back, okay? So there's your situation. You say, well, is that the answer? What does that mean? That is not the answer yet, because we want to know what values are going to mess this thing up. So how about it? If we put x minus 7 to set equal to 0, because in other words, that little factor could do it, or this little guy could do it. Let's bring a line right down the center, and we'll pick up x plus 6 equaling 0. And we have x equaling to 7, because that's what 7 minus 7 gives us, 0, right? And over here, what plus 6 is going to give us a 0? How about it? X equals negative 6. Now those are problem children here, all right? You say, well, Ernie, how can you check that? How can you tell? Let's put it out here. X squared minus x minus 42. Do we get 0 back? So putting in, what have we got here? And by the way, on these factors over here, we said 6 times 7. One of them had to be negative, right? Does everybody see why it had to be negative? Because you had a negative 42 going on here. So let me put that minus there. Could have also played negative 6 and 7, but we would not have gotten the right number in the middle. This is kind of like a little check to unlock our puzzle right there. You see it? It works so nicely. So let's go back and check here. Put that 7 in for x. That's going to give you 49 minus 7 minus 42. And my goodness gracious, that does give us 0. So that's a bad example, but that's what we're looking for. So it checks. Let's see what happens if we put a negative 6 in there. And I may have to drop out my lower third there a little bit. Let's see if we put a negative 6 and we square it. Notice I put a parenthesis around that. Then we're going to have to take away a negative 6 because see what we're doing here? Minus our 42. That is still just a minus sign there. Got a little blurry. That gives me 36. This gives me now plus a positive which is going to give you plus 6 more minus 42. You know what that is? That's equal to 0 also. So it does check out our excluded value. So Samaya, there you have it. Samaya from Bearden, you got the values that we're looking for. That would be x equals 6 and x equals negative 6. Did I say 6 again? My goodness, I'm a little discombobulated today. That's a positive 7 and a negative 6. Those are your excluded values. They check out. And let's see if we can get some phone calls going, all right? 844-686-2378. Mathline is what you're watching today, and we're working our hearts out here to get a few problems taken care of. Once again, we had a little Mathline, hey Mathline going on there. We want to hear from you guys, all right? Let's have some live calls going here, 844-686-2378. We've hit the algebra. We haven't really hit much geometry today, but we've really hit that algebra quite a bit. So let's do just a little bit of maybe some arithmetic to take us down here toward the end of the show. Let's take our 7/8, it says as a decimal and as a percent. All right, so two things we're going to try to do with this 7/8. Now, most of us think about 7/8 just being a fraction. But really what this tells me, when I've got a 7/8, that tells me we've got 7 divided by 8. That's a great thing. All right, and another thing sometimes some of our younger viewers and even some of our adult viewers kind of get a little confused is, what goes inside, what goes outside when we do long division on this? We run the division. Well, the 7 is going on the inside, even though, yes, it's smaller, and the 8 is going to go on the outside. But what happens here is we're going to stretch this out, we're going to put a decimal in there, and we're going to see what happens with it, all right? Now, some of you say, Ernie, could we just type that on the calculator and be done? Sure we could, but let's put a 0, all right? Let's work it out long ways because that's what we kind of expect our younger middle schoolers and elementary school students to be able to do with these things, all right? So let's play with it. It goes in there. We know it goes in there. We know 8 does not go into 7, so we're going to look at 8 going into 70. Big numbers there. And I'm thinking multiplication. If I go 9, I know 9 times 8 is going to give me 72. Over the limit, too far out, way out, okay? So what we're going to do instead is we're going to drop it to 8. I'm pretty sure 8 is going to work. Let's multiply it out. We get 64 and subtract time. All right, so let's subtract. 64 from 70, we get 6 going there. Bring your another 0 down. How about it? Why not? Here we go, straight down there. Because otherwise we're stuck, right? Some of you said, well, we could be stuck anyway, couldn't we? Let's play this thing out. It's going to come out even. Trust me on that, all right? So we're going to say 8 goes into 60. Now, we already know 8 times 8 gave us what? 64. So we want this number to be less, well, it's going to be less than 64 because we've got a 60, right? So think one more down. Let's go with a 7. Ooh, 7 looks good. 7 times 8 gives us what? 56. And here we go, subtract, we get a 4, and bring a 0 down. And we got 8 divided into 40. That finally comes out even. I know what that's going to give us. It's going to give us a 5, all right? So again, remember, when we multiply, we say 8 times 8 gives us 64. Subtract. That's the beauty of division. You're using every operation. You're adding, you're multiplying, you're subtracting, you're dividing, you're doing, oh my goodness, you're doing so many things. You're running so many algorithms in your head, but it's because they're all related. It's all very nicely related to each other. So we got 64. We subtracted. We got 60. We said 7 times 8, which gave us 56. Everybody good so far? Nod with me. You got it. Subtract out, we get a 40. And we got 5 times 8, which gives us 40. We have nothing left to worry about. We are done with this one. And we have that as a decimal. Now, where do we go with a percent? You got 0.875. 875, you got it? Thousandths, all right? Thousandths there. We want to change that into a percent, which means decimal has got to shift 2 places. And that's what we're going to do. We're going to move it 2 places, which transforms this to 87 1/2%, 5/10%, 0.5 as some of us like to call it, but it's 87 and a little bit of chump change, actually 0.5% there. And if you're really borrowing big money, that 0.5% makes a big difference out there, my friends. It does make a big difference. So there you have it, a little bit of arithmetic to finish out the show here today. And hopefully you've had a good time watching us today. We've had a good time being with you. We appreciate you tuning in. We also appreciate you checking us out on Facebook. We've got those things going here. Like us, love us, share us. Problem of the day appears there, www.facebook.com/ing with Mathline and online attached to it. There's one run-on expression, all right? Let's take a look where else you can find us. How about YouTube? YouTube, you subscribe that if you haven't already. Do so. Join us there to www.youtube.com/Mathline. We understand we've done a little streaming this week. We try to do that today, some, so you can catch us there, maybe even the whole show on the YouTube channel this time. Plus, problems of the day are worked out there, as well as our Friday specialized segments, which, by the way, we will have one of those this Friday. You don't want to miss out on. Also, we're going to get circular again on you. But thank you for tuning in today, and we hope again to see you for the next time, and the next time. See you then.